Hi class, today's video is going to be on simplifying expressions with exponents. Now we went over all the rules in class, so I'll just address each one as we come across it. So the first thing we see is we have a fraction raised to an exponent. And we have a rule that says if that's the case, we basically distribute that exponent to both the numerator and the denominator. So for our problem, we're going to distribute the 3 to both the x squared and the y. So this is going to equal x squared over, and then cubed, over y cubed, and the 5x squared y I'm going to leave alone for now. Now we see that we have an exponent raised to an exponent. And we have a rule that says if that's the case, we multiply our exponents together. So that's going to give us x to the 2 times 3. Well, 2 times 3 is 6. And then on the bottom we still have y cubed, and then we still have this 5x squared y. And I forgot my parenthesis. Well, now remember, if we have an expression that doesn't have a denominator, we can give it a denominator of 1. So that might help you to remember that we can basically put that expression into the the numerator, because to multiply two fractions, we multiply the numerators together and then the denominators together. So I'm going to go ahead and do that. I'm going to put the 5 in the front because I personally like to put coefficients in the front. It's kind of the convention to do in math. And everything else I'm going to write next to each other, which is an implied multiplication. And on the denominator, we have y cubed times 1, which is just y cubed. Now I see that we have an x squared and an x to the 6. They both have the base of x, which means I can add their exponents, which gives me x to the 8. So now I have 5x to the 8 y. Actually, let's not write down that y, because at the same time I can notice that I have a y in the numerator and a y cubed in the denominator. Now remember that if there is no exponent, it means that there's an exponent of 1. So if I want to simplify this, I know I can subtract their exponents. Well, remember how we said that if the denominator has a higher power than the numerator, so in this case the 3 is bigger than the 1, then I'm going to subtract the numerator from the denominator, resulting with my final expression for y to lie in the denominator. So again, to kind of say that in a little bit shorter, there's more y's on the bottom, so I'm going to ultimately result with y's on the bottom. And how many go in the bottom? Well, that's going to be 3 minus 1, which is 2. And now I see that my expression only has, one x raised to some power, one y raised to some power, only one coefficient, and all of my powers are positive, which means I am done.